Lesson 5, Advanced Integration Techniques, Integration by Parts, Part 1. Theory. The integral of u dv, or dv dx, equals uv minus the integral of v du, or du dx. Now we'll prove that little result by first of all, we'll start with d dx of the product uv will be equal to u dv dx plus v du dx. Therefore, u dv dx must equal d dx of uv minus v du dx. Now, we integrate both sides with respect to x, so the integral of u dv dx equals, now we integrate that, we're just going to get uv minus integral of v du dx. Now, for convenience sake, we just replace that with u dv equals uv minus integral of v du, just to make it easy to remember. Okay, here's the first example. Now it's a good idea to write out that rule. So we now remove the integral of u dv must equal uv minus the integral of v du. Now, it's very important to decide which way to go in this case. Now, if I differentiate this, I'll just get a 1. So I'm going to set up this one to be u. So u will be equal to x, and dv equals sine x. If you do it the other way around, you end up getting a more complicated thing. Because now you're going to get du is equal to 1, and you get v is equal to, now when you integrate sine x, you're going to get minus cos x. Just be careful with that sign. Okay. So our integral I will be equal to, there it is, uv, u times v, so that's minus x cos x, minus, that's easy to just look back and fill it in, isn't it? Minus, now it's going to be v du. V du, so that changed to plus cos x. And of course that becomes minus x cos x, and when you integrate cos x, you get positive sine x. Just be very careful because you're integrating and differentiating at the same time. So it's easy, particularly with these trig functions, to get it mixed up, plus a constant. Okay, now with this type here, you just got one thing, but you've got something else interesting here. You've got a 1 in front of that. Right, so this is a nice little trick, this one. So let's write that rule out again. See if you can remember it. So it's the integral of u dv equals uv minus the integral of v du. So this time I'm going to let my u equal the inverse tan of x, so I can differentiate that, and I'm going to let dv is equal to 1. So du equals 1 over 1 plus x squared, and v equals x. Okay, so our integral becomes uv, which is going to be x tan the minus 1x, minus the integral of v du, x times that of x, over 1 plus x squared dx. And of course this becomes a half outside of 2x over 1 plus x squared dx, which gives the final result of x tan to the minus 1 of x minus 1/2 log of 1 plus x squared plus a constant.